In this module on using design thinking in research to avoid plagiarism, you would have learned about design thinking. There are 6 steps in design thinking. In this segment, we will learn about the first 3 steps. We will learn how to empathize with the stakeholders, how to interview them, understand more about the problem, define the problem, and then get introduced to methods of ideation. In the second segment on this module on design thinking, we are going to learn the 6 phases of design thinking. The 6 phases are empathize, define, ideate, prototype, test, and implement. So we are going to learn about the empathizing. The first step in starting a PhD research is to explore a research area by reading up extensively and identifying gaps in knowledge or problems that have not been solved. For example, if a student is starting research on the use of organophosphate insecticides in agriculture, the student will collect articles on types of organophosphates, uses, applications, etc., and popular news articles on the impact of the organophosphates. Using a design thinking approach requires the student to identify stakeholders, go and meet them to empathize with them and collect real data. So who are the stakeholders? Stakeholders are people who have invested time or money or any other resources and will be affected by changes in this area. So we need to identify people, groups, organizations which influence the tissue, plot the stakeholders on a matrix based on degree of interest and influence, cluster the stakeholders based on who they belong to, their interest and influence degrees. Analyze and identify the link and relationships between the key stakeholders. Develop strategies to engage these key stakeholders. In this example on organophosphates, the stakeholders that we listed are farmers, agricultural scientists, chemical insecticide industry, people who sell the produce, people who eat the produce or use it, people who live in the vicinity, people who make the organic alternatives, the flora and fauna in this region. If we look at these, those who have the highest influence and interest according to our thinking are the farmers and the scientists. The students can also collect actual data such as soil analysis, biodiversity of flora and fauna in the region, and other parameters. The interview process can help identify different views on why high levels of organophosphates are used in the first place, the cost of the insecticides, alternatives, their effectiveness will be made clear by interviewing farmers. In a design thinking process, there is a focus on getting first-hand information from stakeholders to look for various cues. It is important to step out of the building and start meeting people. A lot of innovation comes from observation and insight. We use an empathy map to understand the stakeholder perspective. So the interview needs to be planned well. We need to find out what the stakeholder thinks, feels, does, hears, and says. To find out what is his perspective of the pain and what is the gain he is looking for. Typically, an interviewer would collect demographic questions and make the user feel comfortable initially, and then dig deeper. To explore and get a deeper perspective, ask open-ended questions, observe, make your own inferences, and record the data. Make clusters of patterns that you observe. From the insights gained, identify the needs for the stakeholder. The next step in design thinking is to define the problem. In the case of use of excess organophosphates in agriculture, we can identify problem statements for each stakeholder. For the farmer, lack of economical resources, lack of information on available alternatives, lack of control over weather and other conditions. For the agricultural scientist, lack of communication with farmers in the amount to be used, lack of control over irrigation methods, and so on. Since design thinking is a human-centric process, the definition and what appeals to each person is intrinsically different. So here is a problem statement that we made. The small-time farmer realizes the environmental problems associated with chemical insecticides and wants an alternative to chemical insecticides which will be economical, risk-free, suitable to the crops grown, have easy to follow instructions, should be available easily. So can you identify who is the stakeholder? What is the problem he or she is facing? And what is the solution he or she wants? We need to develop this. Now that the problem has been defined, we need to look for solutions by an ideation. The third step of design thinking is to ideate on the defined user need. Linus Pauling said, to have a good idea, you must first have lots of ideas. So we need to brainstorm and develop and list lots of ideas. Here is one method for developing many ideas. Get a paper and pencil and start brainstorming. Make a list of the most obvious solutions for the problem. Next, modify, add, subtract the above idea and make it different. Think, how will a child solve this problem? If you had an unlimited budget, how will you solve the problem? If you had no budget, how will you solve the problem? If you had power over natural laws, how will you solve the problem? So was that interesting? So did you get a lot of ideas? Here is one more technique to develop ideas. This is called Scamper. Scamper is an acronym for the following words: substitute, combine, adapt, modify, put to another use, eliminate, and reverse. So substitute. What can you substitute this with? Who else? Where else? Combine. What can you combine it with? Adapt. What might I change? What does this remind me of? Modify. Can I make it bigger, smaller, change attributes? Put to another use. Any other uses? Can we change the context? Eliminate. What can I do without? Reverse or rearrange. What if I turn it upside down? Can I rearrange it? So most of us would have used these techniques when we have to look for alternatives in a research methodology that we have. Very often when we have a difficult methodology, we have to look for indigenous products or substitute or break it into different pieces and see how we can solve this. So use these techniques to practice divergent thinking to make the longest list of ideas. So in the case of organophosphates that we had, we made a list. We wanted to create a website with information on the ideal pesticide or insecticide and have a mechanism for pre-calculated portions of this compound to be used, or invent a process for a pesticide which is used immediately and kills the target pests. The other one would be to be able to detoxify these organophosphates as soon as it reaches the soil when it is not needed, or to identify better alternatives to these pesticides. So the list can be endless. Discuss your ideas with your friends, seniors, and you can identify those which have a potential based on the reaction it evinces from your audience. Here's one more example for getting an inspiration.
Look for other products, organizations, industries, services that may relate to your problem statement or be part of it. Or ask nature. Nature is a good source of ideas for us. I saw a paper where much stronger hollow cylindrical composites were designed based on the natural way in which fibers in a stem of bamboo are organized. In a stem of bamboo, the fibers are organized in a density gradient. So the same pattern was used for making these hollow cylindrical composites.
Was this segment on using design thinking to avoid plagiarism in your research interesting? Did you learn new methods of ideation? Did you learn more on empathizing and defining? I would like to emphasize that empathizing with stakeholders and understanding the root cause of a problem is the most important aspect of design thinking. You need to spend a lot of time actually interviewing the stakeholders and meeting people. Just go out of the building and ensure that you get first-hand information.